Go ahead, Vajinder.
Okay, ma'am.
No, again, we had gone back to non-slide mode.
Now,
Okay.
ma'am.
Yes, perfect. Go ahead, Vajinder. Yeah.
Okay, ma'am. Namaste everyone. My heartfelt gratitude to IAVM Institute for the Advancement of Vedic Mathematics and greetings to all the esteemed dignitaries present here. My special thanks to James Coover sir as well as Swati Dev ma'am for giving me this wonderful opportunity to be a part of this 8th online International Vedic Mathematics Conference. My name is Vajinder Kaur and I have completed certificate course in Vedic Mathematics and currently pursuing BSc Honours Mathematics at Kanya Mahavidyalaya Jalandhar in India under the guidance of esteemed principal ma'am Dr. Atima Srimati Vedi as well as my beloved teacher Mrs. Anand Prabha ma'am who guided me on this path as well as introduced me to Vedic Mathematics. Not taking much time, we would like to start our today's session on the topic Applications of Vedic Mathematics Technique Vinculum, the bar numerals to enhance the speed of arithmetic operations. But before we start our today's session, I would request everyone here to get a pen and paper with you all as we will demonstrate some examples as well as introduce some new concepts to you all. So I hope we can do this all together, not treating this as a presentation but rather as a workshop. Moving ahead, we will understand what exactly are the Vinculum numbers. But before we start, I would like to introduce you to some new concepts. For example, base. So now what exactly is base? Base is a power of 10. For example, 10 raised to power 1 is equals to 10. 10 raised to power 2 is equals to 100. 10 raised to power 3 is equals to 1000. And 10 raised to power 4 is equals to 10,000 and much more. Similarly, we have a next concept which is sub-base. Now, it's related to base somehow as its name suggests. So we can say it as multiples of power of 10. For example, 20, 30, 40, 400, 700 and so on. So the next concept we are going to understand is complement of a number. Now, what exactly is a complement of a number? By definition, complement of a number is the difference between that particular number and the next highest power of 10, which means the next base to that particular number. So to understand it more deeply, we have to get an example here. Let's say number 7, which is obviously greater than 5. So according to definition, the complement of number 7 is the difference between that particular number, which is 7 in here, and the next highest power of 10, which is 10 in this case. So we have to find the difference between 7 and 10. And clearly the difference between 7 and 10 is 3. So here 3 is the complement of 7. The next example is the number 66. So again, according to the definition, the complement of number 66 is the difference between 66 and the next highest power of 10, which is 100 in this case. So we have to find out the difference between 66 and 100. So difference between 66 and 100 is 34 in this case. So it means 34 is the complement of 66. So if you're still confused, let's make it more simple here. For tens complement, we have to have any number, like any number which is less than 10. And we have to find the number which we should add in it in order to make it 10. For hundreds complement, we have to have any number which is less than 100. And we have to find the number which can make it 100. So taking the notice of the previous example, for example, 7 is obviously less than 10. So we have to find a number which should be added in 7 in order to make it 10. So 7 plus 3 is equals to 10. So according to the concept, 3 is the complement of 7. Similarly, as in previous example, we took the number 66. So it is obviously less than 100. So we have to find a number which should be added in 66 in order to make it 100. So to find this number, we can also subtract 66 out of 100. So we get 66 plus 34 is equals to 100. So I hope this is more simple and easy to understand than the previous examples. So now we have to understand the concept of Vinculum here. 18 is obviously close to 20. So there might be a question in your mind that why we are using sub base here. The answer is very simple. We have to make the things very simple rather than complicated. But if we using the next base here, like 100 here, the distance between 18 and 100 is obviously too huge. But rather the distance between 18 and the sub base 20 is as small as 2. So 20 minus 18 is equals to 2 and 20 minus 2 is equals to 18. And this can also be written as 22 and a minus sign put above the digit 2. We say this number as 2 bar 2. Therefore, Vinculum numbers are also known as bar numbers. Why so? Because we often identify the Vinculum numbers if there is a bar put on any digit in a number or not. So now, there might be again a question in your mind that why should we use Vinculum instead of using all the conventional methods which you have been learning since your childhood till now. You have practiced a lot of methods about subtraction and arithmetic operations. So why the hell Vinculum? So this is also why we should use Vinculum, because it is useful whenever we have to replace the digits which are greater than 5 to the digits which are less than 5 in any number. So to understand this particular statement in a deeper way or in depth, just go back to the time in your childhood when you were told to remember the tables of 2, 3, 4, 5, 6, 7, and 8, 9. So just remember the time when you were memorizing the table of 2. So it was very easy to remember that table, wasn't it? And again, memorizing the table of 3 was quite easy, and same goes for 4. But when you started learning the table of 6, 7, 8, and 9, they were particularly hard, weren't they? So exactly, this is a fact that you find it very hard to deal with the numerals which are greater than 5, particularly 6, 7, and 8, 9. But you find it very easy to deal with the digits which are less than 5. So here, there is an example here, 38. So using Vinculum, I converted it into 42, a bar put on the above of 2. Here exactly, 8 is replaced by 2. You can see, 8 is obviously greater than 5, whereas 2 is less than 5. So here, you can see that we replace the particularly hard digit 8 with the very easy digit 2. So this eases up all the calculations and gives a flexibility of representing numbers in different kind of ways. As we represented 38 as 42, a bar put on above 2. So this isn't possible in, I guess, in every, in mathematics, conventional mathematics. So now we have to learn how to convert a particular journal number into a Vinculum number. So let's say consider the number 7. So this is a very familiar example to you all. 7 is obviously greater than 5. So we have to find the complement of 7 from 10. So again, go back to that slide or that moment when we learned the definition of complement, which was the difference between 7 and 10. So it is obviously 3 bar in this case. And the next step is adding 1 to the left hand side, which is 10's place of 7. So this step is very simple, which is 7 is equals to 0. 7 is equals to 1 bar 3. So this number particularly or surprisingly contain both positive and negative digits. This is possible. Right, this is possible for a number to contain both positive as well as negative digit, which isn't possible in conventional methods. So here 3 is in.
Oh, Vajinder, your voice is gotten. Sorry, we lost Vajinder for some time. Can you hear me? Can somebody tell me? Yes? Okay. So till Vajinder comes back, what I'm going to do is I can continue so that we're not. So basically what Vajinder is trying to tell is like any integer can be explained or can be represented as a positive number and a negative number. And the advantages, as Vajinder said, is what we're trying to do is convert a longer or a larger number into numbers. Sorry. She just had to leave, I think. Vajinder?
Yes, ma'am.
Okay, no worries. Go ahead and share your screen. That's okay. Don't worry.
Got it, ma'am.
No worries. Go ahead.
So is my screen visible?
Yes. Go from where you stopped, and that's okay. Don't worry.
No, ma'am, I'm not worried.
Yeah.
So here are three examples here of different kinds, where the first example is a single digit example, and the second example is 2-digit example, and the third one is obviously 3-digit example. So taking the notice of first example 8, which is particularly greater than 5, isn't it? So we have to find the difference between 8 and its nearest base, which is obviously 10 in this case. So subtracting 8 from 10, we get bar 2 on ones place, and adding 1 to the left hand side or the tens place, we get the Vinculum number 1 bar 2. Similarly, taking the second example, 96. And both digits are very greater than 5. So we have to convert these digits into the digits which are less than 5. So here the nearest base to 96 is 100. So according to the definition of complement, we have to find the difference between 96 and 100, which is obviously 0, 4. So placing the 0, 4 on the right hand side of answer with a bar over them and adding 1 to the left hand side, we got the answer as 1 bar 0, 4. Similarly, with the third example, 387, the nearest base to it is sub base exactly is 400. So here again, why we are using sub base? The answer is very simple. We have to make it more simple rather than complicated. Because if we are seeking the next base here, which is 1000, the difference between 387 and 1000 is rather very huge. But if we are taking the sub base 400 here, the distance between both the digits, both the numbers,
It seems her internet connection is little flaky, but that should be okay. She should be able to come back again soon. What we're going to do till she comes back is
put bar 2
okay.
on the right hand side of answer. And adding 1 to the left hand side, I got my answer as 3 bar 2. I would like everyone to have a pen and pencil or paper with them so that they can do these problems together with me. So are you doing?
Vajinder, give them some time to just kind of let them do it themselves. And guys,
Okay,
just give a chance to yourself. Try what is happening here. There is stuff there. Write it down yourself. Take some time, and then Vajinder will explain to you what's happening in one or the other. Or if anybody wants to go and tell what's happening or have any questions, this is the perfect time to unmute yourself, give the answer, or tell how you understood what's happening with 288 or something like that. Yeah?
Yes, exactly. So you can ask your queries if you have any.
Is this thing making sense for everybody? What are we trying to do here? Yeah? Just note or give us a thumbs up. Give us some clues to just understand. Yeah? Yeah. Thank you, OGC. So just maybe say yes, give a thumbs up so that Vajinder knows that things are working well for you all.
Yes.
So the idea is take the number, find the next nearest base number, subtract it, and that becomes the bar number. And you're going to see a very beautiful application of this very soon from Vajinder. And believe me, there are a lot of applications for this. But for today's class, you're just going to see something that we have been struggling always.
Yes.
Yeah, ready to move on? Or Vajinder, maybe just take one or two examples and just explain. Don't need to do everything because it was there. Yeah?
Got it, ma'am.
Yeah.
So I'll explain the most difficult looking example here, which is the last one, I guess.
Yeah.
7,768. So the nearest base to it is obviously 10,000, right? So it will, be difficult to find the complement here. So to find the complement, you can just subtract 7,768 out of 10,000 to find the complement, which is exactly 2,232. But in the bar over these numbers, which are complement, and adding one to the left hand side. So we found the number very easily. It was looking so terrible and hard, but when we did it, it was quite easy, wasn't it?
So for
You guys
example, if
tried?
you had to multiply 7,768 with 2, it may take some time, but when you see ones and twos in the number, then it becomes very easy, right? So that's the idea
Yes.
of Vinculum number, is to really make it easy for us to simplify the calculation.
Yes.
Go ahead, Vajinder.
Yes. Okay. So here are some practice questions. You can note it down on your notebooks and you can do them right now or you can do them later.
Or
You
maybe
want to note it down
give them 2 minutes and start sending the answers. And since
in
you
the chat
cannot
box.
do the bar numbers, you can say for bar 1. Like, yeah, give us some answers so that we know you're enjoying the workshop.
Yes.
Send your anyone, just do one of it or two of it, but send some answers in the chat. Or if you want to unmute yourself and tell your answer, that's wonderful too. But send us some answers. Come on, you guys
Yes.
are doing great. Do it. Or I'm going to call upon people to give me the answers, okay?
Yes. Ma'am will call them.
Uh, need some answers, guys.
So here Calvin is doing the examples, I guess, here.
Perfect, OGC. First answer. Correct, Shreya. Shreya, sorry. You can say 4, 1 bar, 5. Yeah, perfect, OGC.
Now I think they are understanding. I'm very, very feeling proud of myself that I taught you. Okay, Tejansi.
Okay. Give the answers, Vajinder. In the interest of time, we may have to move a little faster. Give the
Yes,
answers,
ma'am.
guys. Take the screenshot of these answers, and also we will be sending we will send the recording of this video so that you have it. So Vajinder, give the answers. We're really running late
So,
and the other person wants to, yeah.
yes, ma'am.
Yeah.
So I will be revealing the answers right now. You can check them if you did.
Yeah. Yeah. Give the answers, Vajinder. Yeah.
It got stuck.
It's okay.
Okay.
Yeah.
Okay, so answers got revealed and you can check if they were right or not. So moving ahead, we're going to understand a Nikhilam Sutra and Vinculum. So there are 16 kinds of sutra in Vedic mathematics, and there is a Nikhilam Sutra in it too, which is a very fundamental sutra and it is used for various purposes. It means all from 9 and the last one from 10. It means we have to subtract a last digit of a number from the 10 and other digits from the 9. So its full name is surprisingly Nikhilam Navtas Charmam Dashta. So you can repeat it after me if you want to. Its pronunciation is like this: Nikhilam Navtas Charmam Dashta. Nikhilam Navtas Charmam Dashta. So now moving ahead, we have an example here. We are going to convert the Vinculum digits into general digits. So we have an example here, 7 bar 1 4. So working rule works from left hand side to the right hand side. We have to firstly reduce 1 from the digit just before the bar digit. So here the bar digit is 1 and 4. So the digit before bar digit is I guess 7, right? So we have to subtract 1 from the 7. So we got it 6. Now we have to apply Nikhilam Sutra, which means all from 9 and the last one from 10 on the bar digits, which means we have to subtract 4 from the 10 to get 6 and 1 from the 9 to get 8. So isn't this easy? We got the Vinculum digit and we converted into the journal digit. So now there is another example here, 5, bar 0 and bar 4. So again applying the same rule, reducing 1 from the 5, we get 4, and reducing 4 from the 10, we get what? 6. So reducing 0 from the 9, we get 9. So here we got the answer 496. So the next example here is 2, bar 6, bar 2, bar 1. So again applying the same rule here, subtracting 1 from the 2, we get it 1. And subtracting 6 from the 9, we get 3. Subtracting 2 from 9, we get 7. And subtracting 1 from 10, we get it 9. So this is easy, right? Moving ahead, we have some complicated looking examples here too, where the bar digits are very in between the other digits, where there are known bar digits 2 and bar digits 2. So here the working rule again works from left hand side to right hand side. We have to again reduce 1 from the digit which is before the bar digit. So take a notice of this number: 7, bar 2, bar 3, 5, 6, bar 3. So we have to subtract 1 from the digit which is before the bar digit. So here 7 and 6 are before the bar digits 2 and 3. So we have to subtract 1 from 7 and 1 from 6. So see, in the answer we have 7 and 5 on those places as we subtracted 7 and 6. Okay, so now we have to apply all from 9 and the last one from 10, which means Nikhilam Sutra on the bar digits. So subtracting 3 from 10, we get 7. And subtracting 3 again from 10, we get 7. And subtracting 2 from 9, we get 7. And the next step is the known bar digit will just remain same. They will remain same, but under a condition, obviously, if there is a bar digit after it or not. So 5 remains as it is. So this is also quite easy, but you need some practice, right? So next example is 7, bar 8, 5, 9, bar 4. So again applying the same rule, we have to subtract 1 from 7 and 9. Why so? Because there is a bar digit after them. So we get in the answer there is 7 and 8. There is in the answer there is 6 and 8 in that place. So we have to apply the Nikhilam Sutra on 8 bar and 4 bar, subtracting 8 and 4 from 10, and 5 remains the same. So in this example here, 5, 6, bar 1, bar 2 and 1. Again,
Okay, I think we lost her again. So what's happening here is in this 5, 6, bar 1, 2, 1. So what's the number before the bar digit? 6. Take away 1 from there, it becomes 5. So 5, 5, and then take away all from 9 and the last from 10 for the 12. Sorry, and it becomes 8, 8, 1. So Vajinder, we couldn't hear you, so I continued the talk. That's okay. Vajinder,
ma'am.
yeah, no worries. Go on to the next slide. Yeah.
Yes, ma'am. I gave them a minute to go through it. Maybe these examples are hard for them.
No,
So
we cannot see the next slide. Can you click on this next slide? Yeah, this one.
Okay, ma'am, I
Right?
clicked.
Yeah.
So you can note down the practice questions right now and the answers too, so that you can do them later.
Give 2 minutes for them to at least take a screenshot. Yeah, take a screenshot.
Yes, ma'am.
And send us the answer.
Okay.
So the rule is simple. Look at the number before the bar digit, take away 1, and then apply all from 9 and the last from 10 for the digits which have bar number. Yeah, perfect. Yes. Yes, Vajinder, you can move on to the next one.
Okay, so these are also practice questions which have the bar digit in between, and the answers with them you can you can take the screenshots of these questions too. Okay, so moving ahead. So now the first uh, application of Vinculum is subtraction, which I'm sure you all find it very hard to do whenever there are some digits which are like 6, 7, 8, and 9. So here we can use Vinculum, like in these examples here, 74 minus 8. So here we are using the conventional method, for example, boring method as usual. But now we are going to use Vinculum here. So what we have to just do is 8 minus 4, which means 4, right? So basically in above classes like 10th, 11th, and 12th, we know that we can subtract the highest digit from the lowest digit to get the negative number, but we don't know how to represent negative number in subtraction, right? So here bar 4 means minus 4. So subtracting 8 from 4, we get bar 4, and 7 just remains the same. So now what we have to do is convert the bar digit. Just simple. So after converting it, we get the answer 66. And how so? Again, I'm going to repeat the working rule here. Just subtract 1 from the digit which is before the bar digit to get 6, and apply the all from 9 and last one from 10 on the bar digit. Moving ahead in another example, which is a 3-digit example here. So see, 3 minus 3 is equals to 0, and 3 minus 5 is equals to bar 2, which is minus 2 in actual, and 5 minus 1 is equals to 4. So now what we have to do is to convert this bar number, and we get the answer as 380, which is very simple. So now there are some other examples here which are the standard, which we do in the standard, like we do it them very usually in some kind of problems, I guess. So here is the example here, 3 2. So here we have to subtract 3 from 2. Usually in conventional methods we can't do so, but here we put bar 1 here, and subtracting 4 from 1 we put bar 3, and subtracting 6 from 5 we put bar 1 here, and 3 remains the same. Now what we have to do now is to convert this Vinculum digits, Vinculum number, into a journal number using the working rule which we just learned before the slide. So converting these Vinculum numbers, we get answer as 2869. So again, the next question is 4185 minus 165. So here, subtracting 7 from 5, we get bar 2. 8 minus 5 is equals to 3, and subtracting 6 from 1, we get bar 5, and 4 minus 1 is equals to 3. So again, converting this Vinculum number into journal number, we get the answer very quite easily. So now there are some questions for practice here. You guys can do it right now.
Just of time, Vajinder, we really ran over. Give the answers.
Yeah.
Let them take a screenshot. So basically, what Vajinder was trying to do it in a workshop was gave us a tool called Vinculum, which will help us do subtraction very easily, where we are not doing the borrowing part, just taking whatever is bigger number, subtracting it from the smaller number, and easily then converting the bar numbers into the regular numbers, right? Which was a beautiful way of going around without having to borrow the numbers. Right, Vajinder? That was the